Okay, so here we are up at the computer. We're using Mathematica, and we've written a little program. We haven't run this program yet in the for loop yet. We're using a Mathematica function called prime pi. And what does prime pi do?
So it counts the number of primes less than or equal to the in a range. It's less than or equal to the top number in a range.
Good. So prime pi of 5 would be what?
3.
Why?
Because you have 2, 3, and 5.
Okay, so prime pi tells you the number of primes less than or equal to. And what I'm doing is I'm starting at a number. Let's say 5. I start at 5, a equals 5. And then I need to create 2015 consecutive integers. So what's my top integer going to be if I start with 5?
It's going to be 2020.
Why?
Because so you have 5 as your starting integer, and then you have 2014 more.
Okay. So what's the top number going to be?
2019.
Very good. So I have to go up 2014 more because I count the one I start with. So then I just need 2014 more. And I take prime pi of the top number, which tells me how many primes are less than or equal to that top number.
Yep.
And now I do something a little weird. Subtract prime pi of 1 less than the bottom number. Why did I have to do 1 less than the bottom number?
Because if the bottom number was a prime, you'd be subtracting 1 less than what you wanted.
Yeah. And so we did it with 5 in 2014 already, and we found that there were 304.
Yeah.
So your instinct was right. To find 15 consecutive primes, we're going to have a really big number. But now I'm going to start at 5, then I'm going to go to 6, 7, 8, 9, 10, 11, 12, all the way up to 19, and just see what we get. So here's what we get. 304 when I start at 5, then 303 when I start at 6, 303 when I start at 7, 302 when I start at 8, 302, 302, 302, 301, then it goes up to 302. What do you notice about that sequence of numbers?
Well, most of the time it looks like it's decreasing.
Okay, that's true. Most of the time it looks like it's decreasing. Is it always decreasing?
No, because you hop up from 301 to... You hopped 302 to 301, and then back up to 302 here.
Okay.
And then down, and then back up
All right.
here.
Do you notice anything else about that sequence that's counting the number of primes in 2015 consecutive integers?
Well, it looks like it's near or equal to 300.
Yeah, right in the beginning it absolutely is. If I start at a larger number though, let's say I start at 500.
Yeah, you're gonna need to go big.
Okay.
So we need to go really big.
Yeah, we are going to have to go big. We're not going to be able to find it just yet. But I need some other ideas about that sequence of numbers there.
Well,
All the terms are pretty close to each other.
Oh, okay. Let's refine that idea even a little bit more.
In this case, it looks like they're all 272 or 273.
Okay. Let's start at 50. All right. So what else can we notice about that list of numbers?
well, it looks like it only decreases or increases by 1.
Aha. Aha. As you move up and down the list, consecutive numbers on this list seem to only differ by 1. And that says they can be 1 more, 1 less, or equal to. Right? But they're never, it doesn't ever go 296, 300.
Yep.
Or 296, 280.
Yeah.
Okay? So why is that? Why, when I count 215 consecutive integers, then I slide over starting with 1 integer more, am I only losing 1 prime, having the same number of primes, or getting 1 more prime?
Well, the reason you'd be doing that is because if you slid over, you could slide over into a new prime, or you could slide out of a prime.
Okay.
Or you could just slide over and do nothing.
And not get any new primes or lose any primes.
Okay. Why is that?
Well, because you're going up by 1 steadily.
Okay, I'm going up by 1.
And because you'll never get 2 new primes by sliding over 1.
Why?
Because you can only gain 1 number and lose 1 number.
Okay.
So you can only gain up to 1 prime.
All right, we're at 5 minutes. We're going to go next video.
Okay.